Hello everyone, today we're going to continue to talk about this chapter 5.2 and then operations on vectors and then section A additions. Okay, so basically from the last lessons plus we have learned the three very important concepts. The first one is the triangle law of the vector additions, parallelogram law of the vector additions, and also we discussed from the examples we come out conclusion is the addition of the column vectors can be done by adding their respective x component and y component respectively. So basically, today we're going to continue to discuss about these additions, vectors additions. Okay, let's first discuss about the class activity 1. Okay, so in the class activity 1, so basically we're going to draw the objective of this class activity 1. So basically we have to represent graphically the sum of the two vectors and explore some property of this. We're going to continue to discuss more about those vectors additions. Okay, so let's draw a parallelogram first. So we have this parallelogram, okay, in the first place. So we have just the vector u, and we're going to use another one as a v. Okay, so we have these two vectors, okay, in this column. So the first thing is, okay, in this the A, B, C, D parallelogram. So we know AB equals to U and AD equals to V. So basically we have these two functions. The first one, okay, number 1. The A is, okay, let's draw the sum of the AB plus BC. Okay, so AB plus the BC. Okay, in this case we can just use the triangle. We can use the triangle law of the vector additions. So because the point from A to B and then B is moving up, so we can simply draw a line vector here. So this is represented by AC. The answer is AC. Okay. Okay. Afterwards, so basically, how to express AB plus BC using U and V. Okay, so now let's look at this. Okay, so basically, okay, from here we know that, okay, AB plus BC. Okay, so because parallelogram ABCD, so BC is parallel to the AD, right? And because these two lines is parallel, and BC equals to AD. So from here we know that BC equals to, in terms of vector, equal to AD. So AB plus BC equals to AB plus, here we change it, so here we change it AD, right? So, because we know that AB equals to U, then plus AD equals to V. So, from here we can know that, okay, so the answer, therefore, AB plus BC equals to AC and equals to U plus V. Okay, so this is the first question, right? And now we move on to the next question, B. Question B. Question B, we're going to find out is AD plus DC. AD plus the DC. Okay, so again, AD plus DC. So from line we know that that is also equals to AC, right? Because the object is moving from here to here, and from here moving to here. So initial point and terminal point. D is the intermediate. D is the intermediate point, right? So that is also AC. So then let's say, okay, because in this parallel from A, B, C, D. So because this line DC parallel to the AB, DC, AB, and DC equals to AB. So we have the direction, same direction, parallel to same direction, and same magnitude. So then we can come up this. Then we can come up this. So we can come up this. So DC vector equals to the AB. Right? Okay. So from here, that's very important. We continue. Okay. Because AD plus DC equals to AD plus. From here we change it. This one, we're going to change to AB. So now we get an answer is AD. AD is V plus AB is how much? AB is U, right? AB is U. You get U. Okay. Therefore, AD plus DC equals to AC and equals to V plus U, right? Okay, so that's the answer with this. So now, okay, we're gonna find out a very important relationship from A to C. So what is the relationship? So what is the relationship between A and B? Okay, this is the thing we're going to find out. Okay, we're going to discuss, right? AD pieces, we found out the answer is U plus. So because AD plus BC, they all find out same vector and same result, right? Okay, and in the A, we also can find out is that this, okay? AB, we can see AB plus B, AB plus the BC. So we also find out that is diagonal, the same diagonal, so it's AC. And then the result is U plus V. So from here we can find out very important information. So we can find out is like, okay, the AB, because they are all the AC, right? AC can be written as U plus V, can be also written as V plus U. So this is very important law. It's called, we can see this law as the commutative law. So this is under a very important law we call commutative law. So we can change them each other but have no issues, right? So because they are all same, u plus v or v plus u, they are all same. So that is very important concept. So from this question, so we can come up this law, commutative law. Okay, so this is very important relationship, right? Okay, let's move on to the next discussion. Okay, next discussion. So discussion. Okay. Discussion 2. Okay. Okay. What do we discuss in discussion 2? Okay. Let's say that. In the discussion 2, so basically, it is 2. Number 2. So in the diagrams we have ABC. AB equals to mu and BC equals to V and CD equals to W. Okay, let's write it. Let's make a drawing. Let's make a drawing. So we have this drawing. Okay, this is A, B, C, D. Okay, so what's the value? The value is the mu, and then it's AB, right? B, and this W. Okay, this is the direction. This is the direction. This is the direction, and this is the direction. Right? So from here, so now let's look at first questions. Number A. A is what? Okay, draw the sum of this AB plus BC. Okay, so AB plus BC. So we already know that. Okay, AB plus the BC. Okay, this is the starting point. So this is the starting point, is ending point. So B is considered one of the intermediate point, middle point. Okay, we call it intermediate point. So from here we can draw a line. We draw a line here. Okay, we draw a line here. So that's the result we get. So get result is AB. Current AC. Okay, we cross this two. Okay, we get AC, right? Okay, from AC, and then the next one is. So the next question is AB plus BC, then plus CD. Okay, so we know. So the next one is, we know this is become AC. Now we put CD. Same thing. Okay, let's apply this one. AC to the CD. Okay, same triangle. We will use a lot of triangle. We use a triangle. We'll find out this. This is the starting point. This is the intermediate. C becomes the intermediate point. C becomes the intermediate point. Then D from the ending point. So we just join up these two together. We join them together. Then we'll get AD. right? So we're gonna answer AD. So how we express them together? Okay, use this formula. Okay, so now we know that. Okay, so this is U plus V plus W equals to AD, right? Okay, so that's simple, right? Now let's look at the B. Okay, B. So what are we going to find out in the B? B is for BC plus CD, right? BC plus CD. Okay, so probably we can draw another line. Okay, we can draw another drawing. Very another drawing, same drawing, same drawing. Okay, same one. Okay, let's see this one. So BC. Okay, so what is this? So can we see that? So BC plus CD. So should we find out? We can find out the C is the intermediate point. A is the starting point, intermediate point, and D is the finishing point, right? The ending point, right? So we just join up this thing. Okay. Then we'll get the answer is because this direction. This is the direction W, B, and U, right? So we will get this is the BD, right? Okay, the next one is this, okay? Let's say AB plus bracket BC plus CD. So we'll have this AB plus BD, right? Again, the same thing. AB to BD. So B become independent point. D is point. A is starting initial point. D is ending point. So we will have this answer. So we just join them together. We just join them together. Then we got AD. Right? Or it should be coming to this direction. From here to here, that means all the way here, right? Okay? So from here we get this AD. So then, now we can write A is U plus AB is V plus W equals to AD as well. Right? So now we can see a very important. Now we're gonna see a very important concept. Okay, so from here, so let's say, so what is the relationship? So what is the relationship between A and B? So what is the relationship between A and B? Okay, so that's very important concept here. Okay, let's look at this. So V plus bracket plus W equals to V plus. So what is this? We find out this very important. That is called associative law. So we can find out this actually that is very important concept called associative law. So from here we know another law is called associative law. Okay, so and the bracket here, or bracket here, they're all nothing changed. They are all equals to AD. They are all equals to AD. Regardless this bracket here or bracket here, they're all same. They're all equals to AD. Okay. So basically, so from here we can see that there is very important concept here. Okay, so we found another law called associative law. Okay, activity 1, the second question, right? Okay, now we're going to summarize this. So class activity 1. So in this class activity 1, so basically we have come out 2 very important law. So for these vectors, so basically addition of the vectors. So basically they obey the following rules. Okay, so the first one, the most important one, so if we have a UVW vector, so basically we will have first one is the U plus V equals to V plus U. Okay, so that is we also call commutative law. Commutative law. And then we also have another one. Okay, if U plus V bracket plus W equals to U plus bracket V plus W. Okay, so that is another very important law. We call it associative law. So in this, so basically in today's class, so we discussed for this class 1. So we come up 2 very important concepts. The first one is the commutative law. The second one we are talking about is associative law. Okay, so that is very important concept in terms of the addition of the vectors. Okay, thanks. We have a exercise we have this examples number 8. We're going to discuss in the next class. Okay, everyone, thanks for watching. Thanks a lot. We'll see you in the next video and discuss example 8. Thank you. Bye.